numbers and sequence. In this video, we'll cover Euclidean algorithms. Okay, firstly, it's Euclidean division lemma. When a and b are two positive integers where a is greater than b, we get a is equal to b star q plus r. The value of r is between 0 and b. The remainder will always be less than the divisor. If r equals 0, then a is equal to b star q, which means b divides a. Similarly, if b divides a, then a is equal to b star q. Like we'd see an example here, there are 34 cakes. Each box holds only 5 cakes. How many packs we need to pack and how many cakes are unpacked? We see 6 boxes are required to pack 30 cakes, with 4 leftovers. The distribution of cake can be understood as follows. We have total number of cakes 34, which is the dividend A, and 5 number of cakes in each box, which is divisor B, and 6 number of boxes, which is a quotient, and the leftover, that is the remainder. Now let's see an example problem. Find the quotient and remainder for the given value of A and B. Here A divides B. Given A is equal to 12 and B is equal to 5. So we know A is equal to BQ plus R. If A is minus 12 and B is 5, we have to find Q and R. At case Q being minus 3 and R being 3, we get A is equal to minus 12, such that the quotient here is minus 3 and the remainder is 3. Euclidean division algorithm. So in this algorithm, it provides an easier way to compute the highest common factor, that is HCF. So let's see the step to compute the HCF. Using the lemma, we find the highest common factor of A and B. If R is equal to 0, then B is the highest common factor. Step 2 is applying the division lemma. Third step is getting R is equal to 0 and assigning that value as the HCF. If it doesn't get the 0 at a case, we have to continue the procedure. The corresponding divisor is a HCF of A and B. In the above algorithm, will always provide remainder 0 at some stage. Hence, the algorithm will terminate. The repeated application will get the remainder 0. HCF of two positive number is denoted as A and B, and GCD is denoted as GCD. Now let's see few example problem. If the highest common factor of 210 and 55 is expressed in the form 55x minus 325, find the x. So 55x minus 325 is equal to HCF of 210 and 55. Firstly, we'll find the HCF. So 210 can be written as 55 into 3 plus 45. Now 55 can be written as 45 into 1 plus 10. Further, 45 can be written as 10 into 4 plus 5. And 10 can be written as 5 into 2 plus 0. Now we are getting 0 as remainder, such that the highest common factor here is 5. Phi is a HCF of 210 and 55. Now we know 55x minus 325 is equal to 5, such that 55x is equal to 330, x is equal to 6. Prove that square of any integer leaves the remainder 0 or 1 when divided by 4. Okay, let's prove this. Let's take the number as x, be the any integer here, and the square of the integer becomes x squared. So x can be written as 2q and x squared as 4q squared plus 0. So when x be an odd integer, we get x is equal to 2k plus 1. Then x squared is equal to 2k plus 1 whole squared. So on simplification, it becomes 4k squared plus 4k plus 1. So taking 4k common, we get k 4k into k plus 1 plus 1. So we can write 4q plus 1, where q is equal to k into k plus 1. K into k plus 1 is some integer and hence proved.
Thank you for watching. Visit us at needbook.in.